When you think of ancient civilizations, what comes to mind? Pyramids, right? The Colosseum? Well, what if I told you that in ancient India, a totally different kind of revolution was happening? A revolution of numbers, of stars, and, believe it or not, surgical scalpels. This wasn't just old history, it fundamentally shaped the world we live in today. So let's dig into a scientific revolution that gave us the number zero, figured out how the cosmos worked, and even pioneered plastic surgery, all thousands of years ago.
So this wasn't just any old period. It was a golden age where the pursuit of knowledge was like the main event. All across the Indian subcontinent, you had these brilliant minds who weren't just sitting around debating philosophy. No, they were out there observing, calculating, and experimenting. They were laying the groundwork for discoveries that would, seriously, ripple across centuries and change everything.
And really, nothing captures just how massive this was better than this quote from the mathematician Tobias Danzig. I mean, think about that. The idea of nothing, of zero. It wasn't just a handy trick for balancing your books. It was a massive conceptual leap, a breakthrough that literally unlocked a whole new universe of thinking.
Okay, so if you're going to describe the universe in a completely new way, you need a new language to do it, right? And for these ancient Indian thinkers, that language was math. But we're not just talking about counting sheep here. They were building the very architecture of logic itself, the foundation for all modern calculation.
Every huge idea has to start somewhere, usually somewhere small. And for the number zero, it started right here, in this ancient text called the Bakshali manuscript. It wasn't even a number yet, not really. It was just a dot, a simple placeholder to make sure you didn't confuse, say, the number 10 with the number 1. But that little dot, that was the seed of an idea that would go on to change, well, everything. So the idea starts to grow. It goes from being just a simple placeholder to something much more. By the 7th century, this mathematician, Brahmagupta, he gives it a real identity. He calls it Sunya, which is Sanskrit for void or empty, and he defines it with this beautifully simple rule. It's what you get when you subtract a number from itself. And just like that, boom. Zero isn't a placeholder anymore. It's a real number. And what's so cool is how he explained it. He used these really elegant ideas, like debt for negative numbers and fortune for positive ones, to lay out the first real rules for using zero. And just look at this. He gets so close. Almost all of his rules are spot on, even by today's standards. The only place he stumbled, division by zero. But hey, let's be fair. That's a problem that would keep mathematicians scratching their heads for centuries. But the ball just kept rolling. The innovation didn't stop. Fast forward a couple of centuries, and another mathematician, Mahaviracharya, says something that is just mind-blowing for its time. He points out that a negative number doesn't have a square root in the real number system. I mean, he's basically identifying the limits of real numbers and hinting at the idea of imaginary or complex numbers, almost 800 years before they were officially worked out in Europe. That is just incredible. And then there's pi. We have to talk about Aryabhata's calculation of pi. Back in the 5th century, he nailed it down to 3.1416. That kind of accuracy was absolutely essential for the astronomical models he was building. What's really fascinating, though, is that he used a word asana, which means approaching. Some experts think this means he might have understood that pi was irrational, a number you can get closer and closer to but never truly nail down. What foresight! Okay, so you've just invented this incredibly powerful new language, this new math. What do you do with it? Where do you point it? Well, for these thinkers, the answer was obvious. You look up. You turn it to the heavens. You start to map the cosmos, but not with myths and stories, with cold, hard numbers. And here's Aryabhata again, just dropping another bombshell. He uses this brilliant analogy. He says it's like when you're in a boat moving forward and it looks like the trees on the shore are moving backward. He's saying, what if that's what's happening with the stars? Maybe it's not the stars that are moving. Maybe it's us. It's just a stunning piece of scientific thinking explaining the relativity of motion way ahead of his time. And let's be clear, this was a direct challenge to what everyone believed. The prevailing view was that the Earth was stationary, the unmoving center of the entire universe. And Aryabhata comes along and says, nope, the Earth is spinning on its own axis once every day. And he said this over 1,000 years before Copernicus came out with a similar idea in Europe. 1,000 years. But he wasn't done. He also took on one of the most terrifying things people could witness back then, an eclipse. All those myths about giant demons swallowing the sun or the moon? Aryabhata said, forget all that. He explained, with pure scientific logic, that eclipses are just shadows. It's the Earth and the Moon playing a cosmic game of shadow puppets. So simple, so elegant, so revolutionary. And if you want proof that his methods were solid, just look at the numbers. This is his calculation for a sidereal day. That's the time it takes the Earth to do one full rotation compared to the distant stars. Look at that number. The modern value is just a fraction of a second different. I mean, to be that accurate with the tools they had, that is an absolutely staggering achievement. Okay, so just take a breath for a second. As if completely revolutionizing math and astronomy wasn't enough for one culture, there was this whole other world of discovery happening at the exact same time. But this one wasn't about the stars. It was happening right here, inside the human body. So I want you to meet Sushruta. He's often called the father of surgery, and for good reason. He wrote this incredible text, the Sushruta Samhita, and let me tell you, this was not some collection of old folk remedies. It was a detailed, systematic surgical manual. It laid out over 300 different procedures and described 120 different surgical tools, a proper textbook for surgery. And again, it wasn't just a random list of things to do. It was a system. He broke surgery down into 8 distinct categories. You know, things like excision, puncturing, suturing. This methodical approach, creating a formal framework for surgery, that's the giant leap that separates real scientific medicine from just being a craft. And this is where it all becomes so real. What you're looking at are the actual steps for an ancient cataract surgery, straight from Sushruta's text. You can almost feel it, can't you? The precision needed, securing the patient, the steady hand inserting the lancet, the final bandaging of the eye. It's remarkably sophisticated for its time. And maybe his most famous contribution of all? Rhinoplasty. Plastic surgery. See, back then, having your nose cut off was a common punishment. So Sushruta developed this incredible technique to reconstruct a nose using a flap of skin from the patient's own forehead. And the craziest part? That basic technique is still influential in modern plastic surgery. It's mind-boggling. But it wasn't all about surgery and scalpels. There was another side to ancient Indian medicine. A physician named Charaka had a completely different but just as profound philosophy. He said it's more important to prevent disease than to cure it. His focus on diet, on lifestyle, on your environment. I mean, doesn't that sound less like ancient history and a lot more like modern-day preventative medicine? So these incredible breakthroughs, they didn't just stay put in ancient India. No way. These ideas traveled. They moved along trade routes. They got translated into different languages. They were debated in far-off lands. And eventually, they were woven right into the fabric of global science. Their legacy is quite literally all around us. Let's take trigonometry, for example. I know, stay with me. It's basically the math engine that powers so much of modern physics and engineering. And where do its roots lie? They go right back to Aryabhata and his concept of Ardha Jya, which literally means half chord. It was his clever way of relating angles to distances inside a circle. And this is so cool. You can actually follow the journey of this idea just by following the word itself. So it starts in Sanskrit as Jaya. Then it travels to the Arab world and becomes Jiba. Later on, it's translated into Latin, but there's a bit of a mistranslation, and it becomes sinus, which means fold or cove. And from sinus, we get the English word we all learned in math class, sine, a direct line through language that stretches across 1,000 years of history. And this legacy isn't just hidden in our language, it's right there in plain sight. When modern India launched its very first satellite into space back in 1975, what do you think they named it? Of course, they named it Aryabhata. What a perfect tribute to the man who, a millennium and a half earlier, first aimed his country's gaze toward the stars. So all this leaves us with a really powerful question, doesn't it? I mean, if just one ancient culture could give the world the concept of zero, the idea of a spinning Earth, and the basics of plastic surgery, it really makes you wonder, what other incredible knowledge is out there, buried in ancient texts and lost histories, just waiting for us to rediscover it?